Hello, everyone. Thank you for being here. I'm very happy to be in London and share some stuff about GraphQL. So today I'm going to talk about our journey at Aircall and how we migrated from REST to GraphQL. As an introduction, my name is Julien Salvi. I'm the lead Android engineer at Aircall, based in Paris. Also an Android GDE, and I'm doing Android dev in short. I wear short like most of the year. And you can find some like tech content about like Android and Kotlin still on Twitter. I'll share some stuff there. Okay, so what I'll be talking about. So I'll do a quick introduction and set up the context or like our ongoing migration from REST to GraphQL. Then I'll show you how you can set up the Apollo Kotlin client inside your application and like have a big return of experience about like our ongoing GraphQL migration. And then I'll just like conclude and share some resources. Okay, so first a little introduction and the context setup. Okay, so what's GraphQL? So GraphQL is an open source query language and runtime that provides an efficient and flexible approach to data fetching and data manipulation. First, like developed by Facebook and then open source. So 3 main key points here like to have in mind when you are dealing with GraphQL. First, the data efficiency for data retrieval. So GraphQL optimizes data fetching, allowing clients to specify the exact data they want. So no need like to like fetch the whole world to just like have just 2 tiny fields that you really want. So eliminating a lot of overfetching and underfetching as well. Second key point is the single endpoint simplicity. So GraphQL simplifies the client-server interaction by using just one endpoint. No need like to deal with like multiple endpoints with multiple microservices and so on. So only one endpoint, and it reduces like a lot of round trips and streamlining communication. And the third one is about like a strong typing and introspection. With that, you don't have like any surprise about like what will be the type of what you gonna fetch. So it ensures like the clarity in the data exchange, and introspection capability enables like powerful and automatic API documentation. So you know what you're gonna fetch, and you can like manipulate the data without any surprise. Okay, so why we moved to GraphQL at Aircall? So we wanted like to like break our like huge monolith we have for our REST API. So we had like some scaling issue with our REST API, and it was like not modular enough with this big monolith. So we wanted also like a serverless alternative. The desire to create a serverless alternative API that like exists outside the monolith. And also we wanted like some efficiency and data aggregation, and that's like what GraphQL does perfectly. Like the need for efficient microservice communication and data aggregator point, single endpoint, and like very good typing. And while moving from like the big REST monolith to the new solution, so the one with GraphQL, we wanted like a minimum description like for our clients. So due to like a intensive internal usage of our REST API, we like designed the thing like to take advantage of GraphQL with minimum description for our customers. So this was like the 4 main points that like say to us, okay, we have to move to something else, and GraphQL is a very good candidate to that. And so under the hood, how we use GraphQL. So the tech under the hood, on the server side, we are using AWS AppSync. Why? Because our infrastructure at Aircall relies a lot on AWS, and so the backend team went for AppSync. And AppSync offers like many capabilities like filtering, real time, and scalability, and has like very nice integration with some techs we are using at Aircall, like Elasticsearch, DynamoDB, Cognito, stuff like this. Like interacts well with like the whole AWS ecosystem. But on the Android side, we went like to deal with our GraphQL API. We choose like to go with Apollo Kotlin. Many advantages, and just like list a few. Great interoperability with Kotlin. Like the SDK is built 100% with Kotlin. Model generation are in Kotlin. It's the library is multi-platform. You can do like query mutation subscriptions as a caching system, and as a nice support with AppSync and the WebSocket communication, and obviously the awesome community support. Apollo is gold with that. Okay, so our ongoing journey, because it's not yet over. It first back like in 2020 when we first introduced like the first migration with GraphQL. So the first feature that we're using the GraphQL API was introduced like between 2020 and 2021. And then the backend team decided like to break this huge monolith of our REST API. So step by step, we are migrating like endpoints along the road with like the features, tech depth, and so on. So it's still ongoing, but we learn a lot while migrating from like our REST API to the GraphQL one. So now, like you have a bit of context. Let's see how you can implement the Apollo Kotlin SDK inside your application. Okay, so GraphQL and Apollo Kotlin. How to set up it inside your app. So it's very straightforward, like to set up Apollo Kotlin in your Android project. You'll see how like to deal with the GraphQL schema, which will be our source of truth. And we'll see how we can make like queries, mutation, and subscription. Like dig into detail of what is like a query, mutation, and what is a subscription. And we'll see how the Apollo client can coexist with our Retrofit client, which mean for like the REST API communication. Okay, so first you add like your dependency. This is the latest like stable version. Soon maybe the 4.0 will be stable. Then you add your runtime dependency, and like you set your package name. It will be up to you. Declare the service, and you're good to go. Now you need like to download your GraphQL schema and like add your big, huge graph inside your code base. So this what does GraphQL schema look like? And you have like multiple ways like to download the GraphQL. So there's a Gradle function like to download the Apollo schema. Can be like a .GraphQL schema or a JSON file. It's up to you. Both ways are good to go. And so once the schema is downloaded, now you can like create your queries. So in order like to fetch data, we have the concept of query with GraphQL. So it's like the equivalent for like the get in the REST API world. So here you're gonna fetch your data and really the data you want. For example, here I just want like the business hour regarding an agent. I don't want like to query like the whole like agent name, ID, stuff like that. I don't need that. I just need like the business hour. So I can query exactly what I want. We also can like now set up the mutation, which is like kind of like the equivalent for the post put delete operation. So here, like we're gonna send data to like the GraphQL API. So here, like for example, to mark a conversation as read. So This can be also done like the mutation, like to delete contacts, delete stuff, update stuff. So like the big picture is the equivalent really of like put, post, and delete. The subscription, which are like real-time communication. So we set up under the hood like a WebSocket communication between your client and your server, and you will have like real-time update on that. So here, for example, we are listening like new messages we receive when the app is up. So we receive in real time new events, and we're gonna parse and say, okay, well, just need like when a new message received, I'm gonna retrieve the agent ID, conversation, numbers, message count, and so on. Okay, so a pro tip: if you are like dealing with your GraphQL API, you can like take advantage of this plugin made by Jim Mayer to like have auto completion, deep link inside your code from like the directly from the schema or from the query you just wrote. It's very nice, but there is like a new one, especially if you are using Apollo, like a brand new GraphQL plugin, still in development, but like very stable in the end. Same like the same thing as like the previous one, but like with like a better interoperability with all the Apollo ecosystem. And the navigation also is quite better. Like you can navigate from like the code you wrote using the queries and the schema and the generated code made by Apollo. Just like to give you a quick look. For example, I have like my query here, and so I can like deep link to, like for example, the first name here inside the schema. To check what is the type of like the field I want to add or like to delete. I can also like deep link to the generated code made by Apollo, so located in the generated source folder. So here you will have like a whole overview of like all the generated type regarding your schema, all operation you define, all the queries, mutations, subscription. So here you will be able like to see all the generated code made by Apollo. And also the nice thing when you are like building your queries, transcription, Java code. For example, I'm here using like some like queries to get some voicemail transcriptions here, for example. And when I'm using the class generated by Apollo, I can directly deep link here to the actual query I define in my my file .graphql. Okay. Back on the slide now. Okay, so to set up the client and like to actually make the queries or the mutation, so you call the Apollo Client Builder and you set up your server URL, your WebSocket server URL if you have any kind of real-time communication. And you can add like your own OKHTTP client, like to add some interceptor or authenticator logic in that. And then you build your client and you're good to go. Now you can like make requests, for example, like the business hour I was showing, like the query. You get your Apollo client, you call query with your query you've been defining just before, and you're gonna execute this query to get like the answer. And you will have like your answer in a typed way. So no need like to handle like the okay, I'm gonna build my own my own remand entity to say, okay, this is new label, this is not. And, so everything is been defined and generated by Apollo. And I can now send the data to like the repository part. And that's it. Like now, like with just that, you can like now query or mutate like all the things that is available inside the schema. Okay, so now let's see what we learn, like the good and the bad during this like ongoing migration. The first thing, Apollo love Kotlin, and we also love Kotlin, so we love Apollo. Apollo is like 100% Kotlin and multi-platform. That's a huge advantage if you want to explore like some multi-platform implementation. It has a very great support for coroutines and Kotlin flow. And it generates Kotlin code from the schema, as I showed you before, like the data classes for the remote entities and the classes regarding the query and mutations. So here, for example, I can like execute. So I will have like a suspend function. So you can do it like inside the coroutine, or you can use the flow support, especially very useful for subscription. So as it's like real-time like use case, just like listen and emit event. So the flow is like a very good use here for subscription. So here I'm gonna listen the new event on my subscription. I may apply some like retry policy on my flow, and when I like on the collect part, I'm gonna collect my event. So my response when I'm gonna expect. And if there is some error, I can catch the error and like dispatch the error to like the upper layer. And I already showed you like what the Kotlin codegen look like. So another thing is like beware the timeout. Beware the timeout because if your REST API is using like a given timeout you define with your backend team, don't use the same one for the GraphQL API. At least sync with your backend team and other client teams to identify the best timeout, like with like dealing with the new GraphQL API. Because under the hood, the implementation with the resolver and maybe the backend team did switch to query the database in a different way than it used to be for the REST API. So the logic in the behind might be a bit different. So better sync with your backend team, like to define like what should be the timeout for this given usage of this GraphQL API. And if you're using OKHTTP, don't reuse the same OKHTTP client for your REST API. Just like build one for your REST API and build one for your Apollo client. Another thing, the lazy loading. We are in the dependency injection world. We are using Dagger and Hilt to manage our dependency injection. So when only a part of your application, this is like for the ongoing migration. Like for example, only a part of your application, which may be under a feature flag, is using Apollo. You can take advantage of the lazy loading with injecting your client. So Dagger Hilt exposed a lazy interface that differ the resource loading. So for example, here, if only a part of my application uses using Apollo, I can do like a lazy injection of the Apollo client. So it will like differ the inject of the resources, and we gonna get the Apollo client only when we actually need the resource. Another thing, like going step by step, monitoring is key. While you're like developing your application, regarding it, if it will be like develop environment or production, you should always monitor your request. So you can take advantage of like the OKHTTP interceptor in order to monitor your queries and mutation. And on a tooltip side, you can take advantage of Chucker, which is a very nice library, in order like to monitor this query and mutation. And if you want to know more about like this Chucker library, Nicolas Cortis make a very nice talk about that, the very last version of Chucker at the last DroidCon. So how to use Chucker like to monitor the request? So you're gonna define your Chucker collector with like a bunch of setup if you want to show notification and the retention period of all the logs. Then you're gonna build your Chucker interceptor. So with the Chucker collector we just defined above, if you want to redact like sensible headers like auth token and stuff like this. And then it is like also good like to always read the response body in case of error, stuff like that. And then it's just like configuration if you want to use some shortcuts inside your application to directly access the Chucker activity. And then you inject your Chucker interceptor into your OK HTTP client. And you're good to go to use Chucker. And I'll show you a little demo about that. I'm back on Android Studio. So this is my device here. I'm gonna launch aircall. And you can see at the top, lots of queries are happening. So if I'm checking that, I can see all the query that has been like triggered when the application has been launched. So for example, I can like go to this one when it's like a query to subscribe, a mutation here, like to subscribe to a client update, a contact update. So you can see like a bunch of information, having like an overview, what was the endpoint, the status code of the response, how much time actually the response took. So it's very good like to monitor if like some query or mutation are slow, and if we need like improvement on that. And also you can catch if you like did bad stuff like triggering multiple queries at the same time in order like to optimize your entire like query flow. Okay, so now back to the slides. Another thing like we were like experimenting, well, like especially dealing with nested queries, is very nice. It's powerful, but with great power comes great responsibilities. So it has like a risk here, like using nested queries. So GraphQL offers many capabilities. One of them is the support of nested queries, so you can like do multiple queries in just one query. This is pretty efficient when you want to aggregate a lot of data at the same time. But the response time might increase a lot if you fetch a lot and aggregate a lot of data. So you should always monitor when you are dealing with nested queries. Always think with your backend teams to find the best solution. So here, for example, we have like a list of conversation with a bunch of data, and we wanted like to get the latest message for a given conversation. So at first, like inside the query, we add like the possibility to use like the nested query, which is list messages. So like to get the latest message given a conversation. So when we first like did that, the query took like 7 to 10 seconds. So it's like, okay, we have the data, but it's like, it will be a no-go for like production. So we think with the backend team and they found like the root cause and stuff like that. So in the end, we found multiple solutions. One possible here, for example, was to expose directly the last message inside the GraphQL schema. But there was like also a lot of work on like under the hood to like optimize the SQL query in the database, managing the indexes in the database in a better way. So there was like a lot of optimization behind that. It could have been like the same API, like just using the list message. But really, like the optimization was on the backend side. So if you spot like this long query, always think with your backend teams to try to find the best solution to like improve the whole thing. Okay, and a thing that was like pretty hard like to deal with, subscription. Subscriptions are very cool, like having like real-time communication. So this event is very nice, but it's not easy at all, especially when you have an AppSync backend. Okay, so subscriptions. Subscriptions are like long-lasting operations. So our WebSocket, and the connection is maintained like mainly using like the WebSocket technology. So we can like receive events in real time. So the data is pushed to the socket and listen on the client side. And keeping the connection alive is not that easy. And things get more complicated with an AppSync backend. Spoiler alert, we had to build our own AppSync protocol to better handle the token refresh on our side. So we had like a few like problems with WebSocket and like with subscription. So for example, we didn't add at first a retry strategy for reopening the WebSocket. So after we saw that an API was exposed in Apollo, so with the WebSocket reopen when. So when you get like an Apollo out exception or like the retry is below 3, we're gonna like reopen the WebSocket, like turn it off, you turn it on, simply as that. But how this Apollo out exception is actually triggered. So in order like to reopen this this WebSocket communication, inside our Apollo authenticator, when we had like an issue with the WebSocket, like okay, the connection has been lost because the authentication has expired, something like that. So we're gonna call the close connection function that are exposed in the Apollo client through the subscription transport network, and we're gonna call the close connection method with that exception in order to trigger the reopening of the WebSocket. So with that, we was like we were happy and say, okay, we found like a first solution like to reopen the WebSocket. But few months after, some clients still complain about like, okay, no, not receiving message in real time. The WebSocket looks like dead on the client side. So we're investigating like some like this socket disconnection issue, and we saw some like WebSocket subscription issues on the repository of Apollo. So there was like some issue with like changing the server URL in like much more real time, which was like really needed, especially for AppSync. Because when you set up your WebSocket server URL, the authentication has to be passed inside the URL, and also inside the other things that are managed inside the AppSync protocol. So this is like just like a we expose like a plain URL to the Apollo builder. But every time we receive a new authentication, so a new token to be used for the WebSocket, the first trick was like, okay, we can only like restart kind of the Apollo client, but it's not very the most efficient way to do it. So resetting the whole client, it like was just like the not good decision to take. So we thought about it like, okay, if we add like a lambda here, we can like trigger the WebSocket server to be reset every time we have a new token. So we can set like the good server URL with the right authentication inside of it. And with that, we take a look at the Apollo repository. There was no ongoing development for that feature, actually. So as Apollo is open source, why not contributing ourselves to the Apollo client? Yeah, it took like maybe 2 to 3 weeks, like from like the implementation to the release of the Apollo fix, and the Apollo maintainer was like very kind and very helpful. So we had like a very good discussion, and the fix was there like couple weeks after we implemented the actual fix, so it was pretty fast, and it changed a lot of things on the other side. So the WebSocket are now kind of stable, let's say. Another thing that is like quite difficult, not difficult, but bring a bit like a brainer here. It's the error handling. So error handling with GraphQL is quite different from the REST API. Error can be exposed in multiple ways. So in queries or mutation, it can be accessible from the Apollo response class, or an exception can be thrown. And Apollo responses expose like a list of potential errors. So you have to part the whole list to see, okay, what kind of error did end up with my query or my mutation. So you have like multiple source of truth and multiple error parsing. So for example, here I have my mutation, I want to send a message. I'm checking if the data is null or not. If it's null, maybe there are like some GraphQL error, so I need to parse this error. Or I need to catch the exception in order, like maybe an exception was thrown by Apollo. And I need to do multiple parsing with that. So parsing the error, parsing the GraphQL error. So you have a lot to do with like dealing with errors with like Apollo. It's a bit like frustrating, like to have like this big boilerplate just for errors. So we didn't find for now the right solution to do it. Obviously, you also need like to sync with your backend team to have like a proper error management system. But with Apollo for the next one, the error handling, I think, in my opinion, is starting to be more neat. So we'll do some experiment with that and see how we can like better manage like the whole error handling thing. Another thing is like the schema automation. So this is very important if you want like to update your schema automatically and not like dealing with it manually, because it takes time for you. So why not automate all the things? If you're like backending, like went in like huge development, so they are pushing a lot of things inside the the schema. So at some point you will have an update almost every day. And if you are dealing with multiple flavors, like staging, production, QA, whatever environment you use, this is like highly recommended because you're gonna deal with multiple schema. So let's see how we did that on our CI side. So we are using GitHub CI. So we set up a job like to pull the GraphQL schema. Like thanks to the appsync command line, we get the schema, and then we pull the schema.json, and then we add like a small script inside of that. So in order like to make the pull request in our repository, so we check if there are like some updates in the schema. make the the new branch and open the pull request on our side. So like every morning we have like the new schema updated with what has been developed by the backend teams. So every like pull request that has been pushed, if it's successful, okay, no need to go further. We merge it in the develop branch. If it has failed, we check out the branch and fix if like some schema in development that has changed, the use of a query or mutation and so on. If we like can't fix it because like there was like a huge breaking change or like the schema that has been pushed breaks all the things, we cancel the MR and we say hello to our backend teams to say, okay, what was the problem? And when you are dealing with multiple flavors, you will have like multiple schema to maintain, and this will lead like to multiple updates and potentially be more error prone. So multiple flavor equals more maintenance. So you have to keep in mind that the more flavor you have, the more schema you will like need to deal with. And one last thing, if you have any Apollo issue, the Apollo community is there for you. And the Apollo community around Apollo GraphQL is quite amazing because Apollo Kotlin is an open source project, so you can like go through all the sources, open issues in their GitHub. The maintainers are very active and very helpful, and there are people that are like gold. If you have any question, issues, stuff like that, they are very responsive. Open an issue in GitHub, ask any question, or like ask something in the Kotlin Slack. They will be there for you. And they are working on the Apollo 4.0 version in beta right now. And there's a lot of good features. The new plugin, new error management, and lots of things like the reason note is quite huge, actually. So lots of good things will be happening with Apollo. So to conclude, few key takeaways. Why it was the right move, Apollo Kotlin for sure. Easy integration with our application. The great support for coroutine and flows. Also the strong typing, so no surprise with the type when you are dealing with your REST API. The combined queries, nested queries, it's a very nice thing. The Apollo community for sure. And big love to the Apollo maintainers also. And not the bad, but the areas to watch. So you always need to collaborate, speak with your backend teams while you are defining your Apollo schema, especially like be involved in the API design. So this like API is going to be used by clients. So try to be involved in that like API design. The error handling is not like perfect for now, in progress. Subscription aren't always reliable, but useful, but not always reliable. And Apollo App Sync support also, like we had like many trouble with that. Yeah, that's pretty much it. Like there is a bunch of resources, like classic Apollo documentation, like for Kotlin, generic GraphQL knowledge. The very nice video from the Apollo GraphQL Summit. If you want like to dig into like some very deep tech around GraphQL, the AppSync documentation and so on. Okay, so that's a wrap. Thank you, everyone. Hope you have some fun with GraphQL. Thank you.